Welcome back. In this unit, we're going to talk about SAS, the Supervisory Attentional System. In the first video, which is Module 7.1, we'll talk about SAS as short-term memory. And in 7.2, we'll talk about SAS as working memory. Remember, if you, from the last unit, we said that there are two attentional systems. Attention system 1 with these three things, and attention system 2 with selective attention, resource, attention as a resource, and SAS. So SAS is nothing but the short-term memory or the working memory. Again, short-term and working memory are different conceptions of the same construct, the SAS. One is a simpler conception of it, and working memory is a more complex conception of it. We'll talk about SAS as short-term memory first, then we'll talk about SAS as working memory. Again, both refer to the same SAS. It's just that we are conceptualizing in a simpler fashion first, then more complex fashion, and we'll also talk about the need for actually developing a complex conception of the same SAS. Before we do that, we just need to know what SAS is to start with. So what is SAS? Well, SAS is supervised attentional system. It is a control attentional process. And you've heard this term before, short-term memory or working memory. They all refer to the same thing, SAS. It's a form of controlled attentional system. I know it's kind of counterintuitive to think of a memory system like working memory or short-term memory as a controlled attentional process, but that's what it is, though. Now, there are other names to SAS, not just short-term and working memory. Short-term store also refers to SAS. Temporary memory also refers to SAS. So the objectives for this particular unit 7.1, which is SAS as short-term memory, is to talk about SAS in general, then talk about SAS as short-term memory, then we'll talk about how is information lost from STM or short-term memory. So what is this SAS in general then? As we said, it's a controlled attentional process, right? So when we say SAS, irrespective of whether referring to the as a short-term memory or working memory, this is one part in your system where the things you're aware of happens. It's a seat of consciousness in that sense. So if a thing happens and in your mind and if you're aware of it, it invariably happens in your SAS, the supervised attention system. It can be either short-term memory or working memory. Everything we are aware of happens here in SAS. And everything that we process at any given point of time, irrespective whether it is active to your awareness, available to your awareness or not, it happens in this system, the SAS. It's a working system. So, what are the characteristics of SAS in general? Well, SAS is a part of the attentional system too, right? And when you're talking about attentional system too, you know that as a resource, attention is limited. So is SAS. SAS is also limited. Now, limited in what? It is limited in capacity and limited in amount of time. In other words, SAS, whether it is short-term memory or working memory, however you conceptualize it, it is limited in how much information it can hold and for how long it can hold information. It applies to both. But first, we'll talk about SAS as a simple concept, as short-term memory. Then we'll talk about SAS as a more complex construct, namely working memory. So let's talk about SAS as a short-term memory and its limited capacity. The idea of limited capacity of short-term memory was first proposed by George Miller. Do you remember George Miller from the History of Psychology, where we talked about the conference in 1956, where the three important conferences presented, and three important presentations presented on the third day of the conference on September 11th, 1956, and one of those presentations was that of George Miller. By the way, what were the other presentations? You're right. The others were, one was by Chomsky, transformational grammar, and the other one was logic machine theory by Newell and Simon, right? That laid foundation to cognitive psychology. Well, the same presentation by George Miller, right? That was the first presentation or first paper to talk about limited capacity of short-term memory. On average, people hold 7 items plus or minus 2. It changes from people to people, it changes from person to person, but overall, average number of items we tend to hold in our short-term memory is around 7. Later researchers suggested that it's actually even lower than that. It's actually 4 or 5 items plus or minus 2, not even 7. Now think of SAS as, or the short-term memory as a bottleneck. Remember, when we talked about sensation perception, we said that your sense organs, for instance, your vision, right, your eyes, they capture 76% of information, a lot of information, 76% when compared to the information out there in the environment that is in your visual field, right? A lot of information, 76% of information is held at least for 250 milliseconds in your sensory memory. Well, your long-term memory holds information, unlimited amount of information, theoretically at least. Now, the system that connects sensory memory with long-term memory, if you remember from our discussions from the big picture videos, you know that it's unlimited, and this one is 76%, and the short-term memory only holds so much, only 7 items. So it's like a bottleneck in that sense. And for that reason alone, if you remember, sensory memory holds 76% of the information. Short-term memory can only hold so much of information because of limited attentional resources. You need a subsystem that can actually help you move from a lot of information to manageable information that can be perceived in short-term memory. Guess what that process is called? You're absolutely right. That is attention. So we hold only 7 items in our short-term memory. The question is, can we overcome this bottleneck? Can we hold more than 7 items? Let's see if you can do this. I want you to go over this task. I'll show you a list of letters presented to you. In fact, a string of letters presented to you in the next slide. I want you to remember as many letters as you can. Okay, here we go. Please don't write it. Okay, I want you to recall now on a piece of paper as many letters as you can. I suggest you pause here for a second, then come back and we'll talk about the answers for this and see how many items you remember. Well, I hope you pause the video and recall. And do you know how many letters you remember? Well, it's typically 7, right? Maybe 9, maybe 10. It's like around 7, right? Some people have remember fewer items, others remember more, but on average, it's around 7. Um, it's interesting, right? That the question is, can you actually increase this number? Can we overcome this bottleneck? Can we remember more than 7 items? Well, this is what I want you to do next. Let's try another list of letters and see how you do this now. Are you ready? Again, another list of letters. I'm going to show you, and I want you to remember as many as possible. Please note, please do not take notes. I want you to remember in your mind as many as you can. Here we go. Are you ready? Okay. Okay, recall now. What? Yes, you're 100% accurate in the first case, right? In the second case. In the first case, though, you were not 100% accurate. You only remember seven or on average seven items. But if you see, these were the same letters, right? This is a list of letters presented to you the first time. This is a list of letters presented to you the second time. It's reversed. Do you see that? The same University of Southern Indiana. But here, in the first case, you only remembered seven items, but in the second case, you actually remembered all the items 100%. Why is that? I want you to think about it. Pause the video here, think about it, and I will talk about it in the next slide. Well, the reason why you remember the letters in the second task is because you have grouped those items, right? University of Southern Indiana. University, those letters were grouped to form one chunk that meant something. University of Southern Indiana, right? So this grouping of items based on some criterion. In this case, the criterion was a word, right, which has some meaning to it. This grouping of items based on some criterion is called chunking. In other words, you're taking same items but grouping them based on some criteria. In other words, you are processing these items by recoding these items, like these are list of items, but you're recoding them by chunking them into groups, right? Then trying to remember this as a unit. So instead of having 24 items, you have manageable chunks of say 3 or 4 items with 3 or 4 items in each chunk. Well, for list of items like University of Southern Indiana, it's naturally chunkable. But for a randomly selected list of items, it might not be possible for us to actually chunk them. So it takes a lot of time to recode them, chunk them, remember them, and then recall. Okay, we said that we're talking about limited capacity of short-term memory, and we said that can only hold information like 7 items, limited amount of information, but it's also limited in time in the sense how long you can hold information in short-term memory. As we know, the sensory memory holds information for a fraction of a second to few seconds, maybe depending on the sense organ, but for the visual sensory memory, it is for around 200 to 150 milliseconds. In the long-term memory, though, the information is at least technically is held forever, right? Now, in between those is this short-term memory, right, that holds information for longer than a sensory memory would hold, which is for fraction of a second, but actually holds for a few seconds to a minute maybe. For visual system though, which we are more interested in, the information is held for 15 to 30 seconds. And after that, the information, new set of information enters the system again. Now, have you seen this movie Memento? this person has the short-term memory loss, right? The person can only hold information for 30 seconds, and then he has to and he cannot move that information to long-term memory, so he has to again redo the process. So the point I'm trying to make here is that there is a limit in terms of the amount of time you can hold information in short-term memory. It's not just the amount. For the amount, you can always chunk, but what about the time? What can you do to overcome the bottleneck of time? Can you remember? Can you remember information for, can you hold information in your short-term memory for longer than 30 seconds? Just think about it. Before we move on to the next slide, where we'll talk about different ways of holding information for longer than 30 seconds, this is what I'll ask you to do right now. I'll give you a sound that you might not have heard in your life, so there is no way you can make meaning out of it. But I want you to hold this information in your short-term memory for longer than 30 seconds. Are you ready? Okay, let's try this. Kashmora. I'm going to tell it one more time. I'm going to say this one more time. Kashmora. Hold it. I'm going to ask you. Hold it. Okay, what is that word? What is that sound? That's right, it's Kashmora, right? Well, how did you remember that? How did you hold that information for longer than 30 seconds? Well, you repeated that information in your head over and over again, right? That's one way of overcoming the limited time. That's one way you can hold information for in your short-term memory for longer than 30 seconds. It's called maintenance rehearsal. Maintenance rehearsal is repeating the information or reciting the information in your short-term memory over and over, right? So we'll talk about maintenance rehearsal and other ways, if there are any, of holding information in your short-term memory longer than its duration in the next slide. Okay, so one way to retain information in your short-term memory for longer than 30 seconds is through maintenance rehearsal, and that's what you kind of did, where you repeated the sound in your head over and over again. It's like a rote rehearsal kind, where you're holding the information and just repeating it. Now, there is another way of doing it. It's called maintenance rehearsal, where you're trying to actually, it's kind of similar to chunking, but it's not, in the sense that you're trying to connect it with something you already know. Like, for instance, some of you might have done this. When I said Kashmora, you probably are Kashmora, where you probably have divided that into and tried to connect it to something you already know, like cash and more, cash more, Kashmora, like more cash, cash more, right? You're trying this Kashmora, which is a new sound, and break it down into cash and more, and cash is related to the cash money, more is more, cash more. If you did this, then the way you have held information in short-term memory for longer than duration is through elaborative rehearsal. Elaborating the information in your short-term memory will also help you hold information in your short-term memory for longer than duration. But in fact, it's not just holding information in your short-term memory for longer than its duration, but it also helps you move the information to your long-term memory when you make elaborations, connections to something you already know in your long-term memory. So these are two ways of holding information in your short-term memory for longer than its duration. Now, the next outcome is to talk about how is information lost from the short-term memory, or SAS. All right. Now, there are two possible explanations, or there are two different opposite theories on explaining how you would lose information from your short-term memory. In other words, Why do you lose the information in your short-term memory after 30 seconds? What happened to that? What is the reason for losing the information? There are two explanations, as I said. One is through decay, the other one is through interference. Decay is when the information get lost over time. You can see the traces of memory get disintegrated over time. It's like just passage of time, right? And the information gets decayed. So it's a decay theory. And this particular explanation was reinstated uh, by the experiments conducted by Brown and Peterson by using a specific kind of experimental design or task called Brown-Peterson paradigm. So we'll talk about Brown-Peterson task or Brown-Peterson paradigm, what they did, what the logic of the experiment was, and how they concluded that the way we lose information from our short-term memory is through decay, which is simply losing information over time. In this case, it's 30 seconds. Now, another explanation for it is that you're not losing information because the information is sitting there and getting disintegrated, but in fact, this information that is held in your short-term memory is replaced by new information, or the old information itself does not allow the new information to be held for longer than 30 seconds. So it's interference. Interference needs other information to interfere with you holding information in your short-term memory for longer than 30 seconds. Does it make sense? So it's like decay, information gets disintegrated on its own. Interference where other information will replace the information that you are talking about. Now we'll talk about these two explanations, and we'll talk about these two paradigms that looked at this explanation. One is the Brown-Peterson paradigm that suggests decay is the way we lose information. The other one is the digit probe paradigm, which talks about the interference as a way we lose information. And it's a very interesting set of experiments, and it's beautiful. We'll talk about that in the next few slides. So let's talk about the Brown-Peterson paradigm. Again, the Brown-Peterson paradigm is a very specific kind of paradigm. The main point of this paradigm or this particular task was to make sure that the participants are not repeating the information in their short-term memory. So they developed these very specific design or experiment to prevent participants from repeating the information, because they just wanted to see, is the information in your short-term memory lost just by passage of time? So they were trying to manipulate time, but also not allow the participants to repeat the information. It's a very interesting, tricky situation. So this is what they did, and this is what it means when you say Brown-Peterson paradigm. So the primary task of the participant is to remember a three-letter trigram. It's very easy, right? Just like G and T. Well, if you're just given these three letters, you can just repeat these letters over and over and try to remember it, right? That would be easier. Well, to prevent that, what Brown and Peterson did is that after presenting these three-letter trigrams, participants were presented with a three-digit number, for instance, 728. And the moment they get this number, the participants have to they have to count backwards out loud by 3. So if first they get 3 letters trigram, for instance, let's say G and T, then they see a digit, 3-digit number 728, then they have to start counting backwards right away. So you have to say 728, 72, I'm sorry, 728, 725, 722, 719. Do you see that? How difficult it may get if it's continued? Well, after a varying amount of time, they were asked to do this distraction task. That's what it was. The task was, the aim of this task was to distract them from repeating these letters. So they varied the length of distraction task. Okay, either they repeated, counted backwards, they did not count backwards, or they counted it backward for 3 seconds, or 6 seconds, or 9 seconds, or 12 seconds, or 13 seconds, or 18 seconds. And what was measured was the DV was the recall accuracy averaged across several tens of trials. The idea was to see if with the delay, right? With the increase in delay, the idea was that the accuracy also will drop, suggesting that the information is lost over time. Shorter the distraction task, shorter the time the information had to spend in the short-term memory, and longer the distraction task, longer the time. And because they were not repeating the information, the only explanation they thought for these results was to say that, well, the information just got disintegrated. That's the only explanation for that, suggesting that time is a factor in determining how we use information. So the information, as you can see, as the time increased, right, the accuracy dropped. In other words, um, uh, if the delay was immediate, if they were asked to recall immediately, it was almost 90%. And if they're asked to do the distraction task for 3 seconds, it dropped. For 6 seconds, it further dropped, and so on and so forth. So they suggested that as a passage of time, the accuracy drops, suggesting that you're losing information as a function of time. And the only reason for that is the information gets disintegrated. Now, think about it. Um, they manipulated the time, right? The Brown and Pearson, but Waugh and Norman in '65, they questioned this paradigm. The results of this experiment said, wait a second. Of course, with the increase in time, there is a decrease in recall. But is it just increase in time, or there is more to it? In other words, is the distraction task just preventing participants from rehearsing the information, or the distraction task itself is acting as interference? Do you see the logic here? Is the passage of time also has a confound of interference of the actual task of doing counting backwards. So it's a very, very interesting question, and they try to find answer to this by actually manipulating both time and also interference. It's very interesting, and I'm going to talk about this experiment in the next slide. Because in this experiment, they just manipulated the time. They did not manipulate the number of intervening items, right, or interference, because it's not possible in this experiment. But Vaughan Norman did that in the next experiment, and we'll talk about that in the next slide. Now, here is the interesting thing in the Vaughan Norman study. And the task they used is referred to as the probe digit task. I want you to pay attention here. It seems confusing, but once you get the logic of it, it all makes sense. So just bear with me here, and I'm gonna go over this slowly, so we both are on the same page. Okay, this is what the Vaughan Norman did. Number one, participants were presented with random order of 16 digits. Okay, random order of 16 digits, and these were presented, right, one digit at a time. So they'll hear 7, 0, 8, 4, 1, 6, 0, 9, 5, 5, 3, 7, 2, 4, 7, 8. So each participant in a given file is presented with 16 digits. Okay. Now, here's the interesting thing. After the last digit, right, they hear a tone. After the last digit, they hear a tone. When they hear the last digit, you have to go back to that time when they first saw this probe digit number 8 and recall the digit that is next presented after 8. Do you see that? Again, this is a probe word which is presented definitely at the end of the 16 digit list, and somewhere here, in this case, the probe was here, and there is no way participants would do which one would be a probe one, right? And the participants have to recall the word or the digit following the probe digit. So they have to go back in their memory, right? So they manipulated, right? They manipulated both time and the interference. The way they manipulated the interference was by manipulating the number of intervening items between the to be recalled number and the tone itself. You can see that, right? If this number is closer, right, then there are fewer items. If this number is even further closer, then the number of intervening items between the recall item and the tone are fewer. So they manipulated how far the last item was from the probe item. It was either immediately before it, or 2 or 3, 4, 5, or 16 digits before it. So they manipulated the interference aspect of it by manipulating the number of intervening items. But here is the interesting thing. So it was like two items in between, 4 items, 6 items, 8 items, 10 or 12 items in between. But here is a more interesting thing. They also manipulated the time. In other words, for each, let's say, if only 2 items, if the intervening items are only 2, right? They manipulated the time. There is T1 and T2, where they got more time at one point and fewer and less time in the other condition. How is it possible? Well, the way they did it is they presented the same 16 digits at 2 different speeds. One group heard these 16 digits very fast. So they would hear the 16 digits at a speed of 4 digits per second. So something along these lines: 7084, 1609, 5537, 72478. You see that? The other group, on the other hand, would listen or hear these sounds at a slower pace. Same number of items presented at different speeds. You see that? It would be something like 7, 0, 8, 4, 1, 6, 0, 9. You see the idea? So same number of items were either presented at a faster speed or slower. So that's how they manipulate both the time and intervening items, right? So between the recallable item and the tone, the two things that happen. First of all, the time has passed, and this time passage was either one group was same time, the other group it was fast or slow, more or less time, and they also manipulated more digits, right? It's a very, very interesting. I love this study. We'll talk about the results in the next slide, by the way. So here are the interesting results, right? The x-axis is number of intervening items. Remember, the number of items between the tone and the probe item were either 2, 4, 6, 8, 10, or 12, right? And the y-axis is the accuracy, relative accuracy of the number of relative accuracy. Okay, and you can see there are 2 lines here. This is the line for items presented at 4 digits per second, the fast condition, and this is 1 per second slow condition. In other words, here the information was spent for less amount of time. Here the information was held for a longer amount of time. Correct? Makes sense? So they manipulated the time in this sense, and they manipulated the number of items in this sense. If information is lost by just passage of time, you should see these 2 lines being different. Make sense? Because passage of time, if it's a factor. But you can see these 2 lines are almost parallel, suggesting that the information lost is not because of the difference in the passage of time. Rather, it is because of the difference in something else. What was that something else? And that something else was the number of interfering or intervening items. The more the intervening or interfering items there were, in other words, the more the number of items between the probe item and the tone, right? The worse the accuracy of recall was, irrespective of whether they had more time or less time. suggesting that the reason how you lose information from short-term memory is most likely to be through interference than decay. It doesn't mean that you can't or you don't or you won't lose information through decay. It's just that it's more practical to think, and it's more reasonable to assume that you lose information through interference because new information comes and erases the old information, and this process continues. So, well, this brings us to the end of 7.1, where we talked about SAS as short-term memory. In the next video, we'll talk about 7.2 unit, which is where we'll talk about SAS as working memory. Thank you very much. I hope you like the video and have fun learning.